Hello, boys and girls. Welcome to Mrs. Bandu's Math Minutes. This is for Course 3, Lesson 2.8, Scientific Notation. Okay, scientific notation is a special way of writing numbers that are very large or very small, that would have lots and lots and lots of zeros with in them, usually, in a bit of a shorthand way. As the term scientific notation might indicate, these are often used with scientific applications, things that are very large, perhaps distances in space, to things that are very small, measuring the size of microscopic particles, so forth. So we're going to just explore how those kind of numbers look, how you can change from standard form, which is a regular number, into scientific notation, and vice versa. Also on scientific calculators, such as the kind that we use in math class, sometimes your answers are so large or so small that it does not fit in the screen, and you will get a number denoted in scientific notation. I will show you, so don't let me forget to do that. Please be sure to remind me in class. So back to this though. A number is in scientific notation if the first factor is greater than or equal to 1 and less than 10. And the second factor is a power of 10. Okay, let me make that a little bit smaller so you can maybe see the whole thing. A scientific number. A number is in scientific notation if the first factor is greater than or equal to 1 and less than 10, and the second factor is a power of 10. And by that, here are 3 examples of numbers written in scientific notation. I'm going to zoom a bit now because I don't need the whole width of the page to display. Okay, 1 times 10 to the 8th would be 1 times 10 to the 8th power. You could figure that out with a calculator, or you could simply figure it out by moving decimal points, which we'll talk about in just a moment. 1.54 times 10 to the 7th, this number is greater than or equal to 1 and less than 10. And same thing here, greater than or equal to 1 but less than 10, and the second factor is a power of 10. So it always looks like it's in scientific notation, the number looks like an expression with a multiplication sign in it. Okay. All right, so writing in standard form. At one point, the distance from the Earth to the Moon is 1.513431 times 10 to the 10th power inches. Write this number in standard form. Okay, so basically what you do here is focus in on the exponent. The exponent is 10. This tells us that we're going to move our decimal point 10 places to the right, inserting zeros as necessary so that we can in fact pass up 10 places. So here we go. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, my decimal point goes there. So I had to insert 4 zeros to have that appropriately placed. So that gives me 1, 5, comma, 1, 3, 4, comma, 3, 1, 0, comma, 0, 0, 0. So I believe that's 15,134,310,000. So at one point, the distance from the Earth to the Moon is 15,134,310,000 inches. Okay? If you had to keep using this number over and over and over again, say in a scientific paper, or really even your scientific calculator might not be able to display this many digits, then we could just write it in scientific notation and use it that way. Okay? All right, there is a quick check question for you to see that conversion there. Number 2, writing in scientific notation. The diameter of the planet Jupiter is about 142,800 kilometers. Write this number in scientific notation. So basically what we're going to do is we're going to move our decimal point until there is only one non-zero. Oh, excuse me, I just read the whole thing without showing you. There is only one non-zero digit in front of the decimal point. So that's actually going to be 1, 2, 3, 4, 5 places to the left. Okay, so what I'm left with is the factor 1.428. Once I get to the zeros, I drop them because I'm trying to shorten the number a little bit, sort of. I'm going to use 5 as the exponent because I moved my decimal point 5 places to the right. And the way to check yourself, if you're not sure, if you'll go back and say, okay, if I took this and I moved my decimal point 5 places to the right now, would I get 142,800? And I would. So in scientific notation, the diameter of the planet Jupiter is about 1.428 times 10 to the 5th power kilometers. All right. Also, as I alluded to at the beginning, that we also use negative exponents. Usually negative exponents are used for numbers that are very small and lie between 0 and +1, or between 0 and 1. They don't necessarily indicate negative numbers. If we're looking for a negative number in scientific notation, then that first factor is going to be negative. But the negative exponent does not indicate a negative number. It means a very small amount whose absolute value falls between 0 and 1. Among the microscopic fossils found on Mars, the largest are less than approximately 2.45 times 10 to the -5 centimeters in size. Write this number in standard form. Okay, so because this is a negative exponent, this is going to mean that we are going to move the decimal point 5 places to the left to make 2.45 less than 1, because if there's a negative exponent, that means the absolute value of our number is going to fall between 0 and 1. So again, I'm going to count back to the left, inserting zeros as needed. So I'm going to get 0.00000245 centimeters. Okay, the largest possible fossils found on Mars are less than about 0.0000245 centimeters in size. Okay. Finish your quick check questions. And as always, we will go over this some more in class. So if you have any questions, certainly jot them down, make note of them, bring them to class. It'll give us a starting point for discussion. I look forward to seeing you soon.